Good morning, sir.
Please remain online. We'll be starting this class on Teams in this particular channel. Okay, so please remain online. Let few more students join. Okay, I find the number may be still low. Okay, as compared to the strength. Friends, very good morning to all of you.
Good morning, sir.
Those who have joined late.
Good morning, sir.
Okay.
Good morning, sir.
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 Okay. I think enough of good morning. So.
Good morning, sir.
So as a protocol, please mute all of you. Please mute your microphone because if you, it will catch noise and here this end also lot of noise will be coming. Okay, and it will not be very good experience for all of you. So please keep your mics on. I muted, and whenever it's required, I'll tell you to unmute your mic. Then only you can. Suppose we are having some discussions or somebody will raise his hand, or somebody is responding to my some queries, something like that, or giving attendance. That times you may have to unmute your mic, but otherwise it will be muted. Number one. Now coming back to this particular course, okay, this course of engineering laboratory is something new which we also have started here. You may not be aware, but IIT Kharagpur, this particular session, academic session 2020-21, okay, so this will be, they have started a new curriculum for the UG, and you will be the first batch who will be undergoing through this curriculum. Okay, curriculum means the different subjects you will be taught at the first year, second year, and subsequent department level. Okay, so see, the background video is running. Please do not play with the video. That is another thing. Okay, let it get recorded. Otherwise, there will be multiple copies and multiple times some disruption will come. So please do not stop the video. Okay, of your own. Okay, it has been started. Let it go on. Okay, recording of the video. Now about the new curriculum, this particular lab, particularly we have started two new laboratories for specifically. One is the engineering laboratory, another is do it yourself. Okay, and engineering laboratory for that matter is a combination of the two first year laboratory we had here. One was a electrical circuits and all, and second one was that we have electrical laboratory and one mechanical engineering. Here at mechanical engineering, where is something called workshop we used to known as introduction to manufacturing processes. Okay, now in order to introduce new laboratory, we have to sacrifice some of the experiments, and now here this engineering laboratory will have two different departments will be organizing. It is a combined things. Okay, at least this year. So here you will be going first phase. Okay, still mid of the semester, we'll having 5 experiments conducted by the mechanical engineering departments. Okay, and followed by on the second half of the semester, you will be doing 5 or 6, or depending upon the available time, laboratories at the electrical engineering department. So total there will be around 10-11 experiments there. Okay. Now out of the 5 experiments and demonstration rather, we'll be having a different topics. I'll say the background, but all these things still because everything now is happening virtually, but whole idea of doing any kind of laboratory is do it in your own hand. Okay, in normal situation when it will be offered to the students, they will do in their own hand, of course after under some supervised instruction. Okay, people will be there, they will be able to operate things, they will be able to fabricate things, they will be able to do an experiment and so on. Okay, and the background things, of course the theory and other things will be told before you get into the business. But since this in this pandemic situation, we do not have the scope, unfortunately. So everything will be teaching online. Okay, at least for this semester. Okay, and even the experiments also, which otherwise will be doing physically, it will be done online. Okay, now coming to this experiments, there are different things, because whole idea of these 5 experiments to be done at mechanical engineering department, okay, is to give you some idea how a product can be manufactured, at least some of the, not every aspect of manufacturing, because manufacturing a product is a huge aspect. It requires a lot of science, lot of what you call techniques and so on. But here we'll give you some glimpses, some ideas how starting from a raw material, how a product can be there or a component or the subcomponent of a product. They can be manufactured, they can be created, they can be fabricated. Okay, so for that we'll have different routes. So it's not possible to give you, but we will give you some glimpses how it can be done. Okay, so the component I'm milling, suppose somebody is a simple thing, you take say your a nut or a screw, a bolt. How this can be manufactured, a gear. Okay, so how this can be manufactured. So for that you will be having some starting material. It could be a solid block of metal or alloys, or sometimes it could be some other things. Okay, and from there how do you do it? Okay, so here in this laboratory we'll see three aspects of fabrications or manufacturing. One is machining. Second one is joining or welding. And third aspects will be casting or foundry practices. So to start with, we'll first go through three experiments in the machining aspects. Now, what do you mean by machining? Machining, suppose I have given you a block of, say, metal, say steel or cast iron of certain size. Okay. Now from that, I show you a drawing of a component, maybe a gear. Okay, maybe a simple spar gear or helical gear, and I tell you from this is your material, you get me this job. How do you do it? Probably you will think in order to do it, I need to chip up some material, do some subtractive operation, means you have to get rid of some of material, but in a controlled fashion. Okay, in a sequential fashion. And finally, you would be delighted to get your dimensions, your shape, size, okay, your finish, and within an acceptable accuracy and tolerances. Then only the product will be accepted. So this will be sort of a subtractive manufacturing. Means from a given block, we are subtracting material by the process is known as a machining process. Bit by bit in forms of chip, the excess material which is not eventually going to be the part of the final object, your gear, okay, will become in forms of small chip. So, okay, so that could be a discrete things. Okay, so they can be in forms of say chips. This material will be coming. But how do you cut a metal? Because metal is very hard compared to any other thing. If I give you wood, you have seen how the carpenter does it. Might not have seen it. Okay. If I give you something other softer material, you can cut it. With a knife, you can cut so many things. But how do you cut a metal? But for that matter, because you have to apply some kind of tool like sharpened tool like a knife. But what is important? The job material, it is having metal is very hard, steel is very hard. Okay, it will not, you cannot do it, cut it with a simple knife. So you got to have something which is harder than your work material. Work material means the block of material from which you will be making that gear. Many a times we call it the job. Okay, so you got to have some things. So this is what we call a cutting tool. So cutting tool is not a single thing. There could be so many different types of cutting tool. They are material wise, they are geometry wise, shape wise. Okay, the way they are used on a particular type of machine or equipment, it may be different. So accordingly, we have different types of tool. But in any case, whenever we have machining metal like steel, we cutting tool, which is hardness of which is harder than the job material. Okay. Now friends, for machining, where will you do this machining? You cannot put it on your table and do cutting with that tool because it requires lot of strength. Number one. And second thing, probably you got to give a form to the block of material I've given you because this gear is having certain geometry. Even if I give you out of a block, you give me a simple cylinder of this much diameter and this much height. Simple cylinder. Even for that also, somehow you have to generate that form. So you have to control or you have to remove the excess material. For that, we follow a process called a turning process and facing process. Okay, but when do you do this job? What is your resource? You got to have certain machines to do this thing, is it not? So in machining, we'll come across different types of machines which are known as machine tools. Okay, so here we'll see different machine tools. So in the first experiment, in the machining labs, I will have altogether 3 experiments in machining. So first experiments, you will be able to know about a machine tool called lathe. L-A-T-H-E, lathe. Okay, so lathe here where you can have a specific function, mostly axisymmetric cylindrical kind of job. Okay, whether it is straight cylinder or step cylinder, along with various other operations. So this operation is known as turning operation, but there could be other operations like facing, okay, say grooving, chamfering, thread cutting, and so on. So first experiments will be something on lathe, given particular drawing of the, so that from the drawing you may not have learned engineering drawing as such. Maybe this will be your first exposure to an engineering drawing. Okay, I do not know. So I'll give you a sheet of drawing, at least on the computer. From there you have to understand and you have to realize what this is for. What in 3D form, 3-dimensional form, what does this represent? And how this given drawing, which represents a 3-dimensional physical tangible object, which you can hold in your hand and which is having some value, how we can manufacture on a machine tool or equipment called lathe. Okay, and in fact, since earlier students, your senior students have used to do it in their own hand. In of course, a small group, everything, they used to run the machines and do it. That used to, when they finally see, I used to see what the kind of charm they are getting, because they are, it is their something product. They have manufactured it. But again, here only what at best I can do it. We can tell you the theory of the things, talked about the various components of the lathe, understanding how the lathe is operated. Okay, what are the subcomponent, what are the sequence of operations, understanding the drawing, and so on. This you will learn. And finally, we'll give you a video for all these kind of experiments, elaborate video, so that it will be explained nicely and you will be able to know it. Okay, this is about the first experiments. The second experiments will be a similar machine tool called equipment. I will tell you as of now because you don't know what a machine tool is. So that is known as milling machine. Milling, M-I-L-L-I-N-G, milling machine. So in a milling machine also will be given a drawing of the component. Okay, where you will give a something like, unlike lathe, here we are making a flat surface. Okay, mostly flat surfaces, but it can be do other surfaces also. So here we can have different types of milling, but here we have a something like a special milling tools. So we'll learn about the milling machine and eventually we'll see demonstration wise how a rectangular shaped square shaped things from a cylinder can be manufactured. One end it will be square shaped, Other end it will be an hexagonal shape. How this kind of forms can easily be manufactured. So that is about the second experiments known as milling. Okay. Third experiments, of course, these two machines will be demonstration wise also you will see they will be running manually with some operator. So when you run it, you are the operator of the machine. Okay. So for demonstration, of course, we have taken help of our technicians. So there will be some operator who will be operating the machines, manual operators. But in many cases, say we may have to make a job of not a single job. We may have to make multiple jobs. Okay, and with acceptable accuracy. Okay, then acceptable tolerance. Then how can you repeat the job? Because manually there may be so many errors. So what is the solution? And quickly small batches, similar kind of jobs. And sometimes also there may be fatigue with the worker and all. So from here we'll go for the how, give you some ideas how automation in a machine tool can be given. So we'll see how automated machine can run and execute a job. So in your third experiments, we'll show you something called a experiment and demonstration on theory on turning center, CNC turning center. So it is basically a computer control machine where you have to write a program in standard codes, okay, which machine can understand, machine controller interpreter can understand. And when you execute this kind of thing, okay, so you'll be seeing how through a computer, a motor which actuates the different movements in the machine that can be done. Okay, so you learn how with a program you can make different type of components. What are the language there? Okay, how is such a machine can be constructed which can be programmed and which can be run automatic? Maybe at the entry level program level some operator will be there, but minimum supervision is required. Okay, otherwise it will be only a single operator can run 4 or 5 machines together one after the other, and once machine is completed you'll take out the job, another will be loaded. So this is about the third experiment is on turning center. Okay, so these are the 3 experiments on the machining. Other than the machining, next we'll take you the 4th experiments which will be on welding. Welding, you may be knowing what is welding. You have seen, okay, and many welded components you have seen with different structures, big shapes, okay, your automobiles, bodies, many things are in your day-to-day life, even your house also, domestic out, these your steel almirahs out of a shade, they are just welded at the corners and all this given a rectangular, this what you call shape kind of things, okay, everything. So how welding means joining up two metals. It could be metal plates, metal sheets, metal blocks. Okay, how they can be joined. Okay, there are different ways to do it. One is using, typically they will be melting the things at the joint at create a high temperature with some energy source, and then if the energy source moves, okay, and goes to a different locations, the metal melts because of the heat input and they again resolidify. This is the technique of welding, but this has to be done in a complete control manner with the controlling of the involved parameters of the machines. Okay, so welding basically will be, in order to create this kind of energy source, high energy density source, will have, can be two. One could be on gas welding. You know, gas burners are there in the house. Okay, so how with the gas burners with a then relatively concentrated gas flame will be able to do welding. So that is known as gas welding. We'll be learning that thing. And second aspect will be doing arc welding, electrical arc, ARC. Okay, how arc can be produced with a machine and how that can be used for welding process. What are the requirements there? So what we learn in the welding laboratory, all different theoretical backgrounds, practices of the welding processes, both gas welding, arc welding, and subsequently you will be demonstrated to see how welding is done and how it can join a sheet. What are the techniques are there?